Hello students. Today we are going to discuss the topic factor influencing rate of corrosion and corrosion control methods. First, factor influencing rate of corrosion. In this, the first factor is nature of metal. First, position of metal in the EMF series. Metal higher in the galvanic series undergo strong corrosion and lower in the EMF series undergo less corrosion. And the second is relative areas of anodic and cathode. Corrosion will be severe if the anodic area is small and cathodic area is large. Large cathodic area of the cathode will create demand of more electrons, which can be met by the smaller area of anode only by undergoing more corrosion. The second factor is purity of metal. If the percentage of purity increase, the corrosion rate will decrease. And the next factor is nature of environment. In this we will include first temperature. Increase of temperature increase diffusion of ions in the corrosion medium and it increase the corrosion rate. And the second factor is humidity. Concentration of water vapor present in the atmosphere is known as humidity. If the humidity increase, the corrosion rate will increase. Next, presence of corrosive gases. Corrosive gases like SO2, S2S, fumes of HNO3, S2SO4, acetic acid increase the corrosion rate. And the next factor, pH. The corrosion rate is maximum when the environment is more acidic and minimum when the environment is more alkaline. In general, acidic medium is more corrosive than alkaline or neutral medium. Next is corrosion control methods. The corrosion is controlled by the following methods. First is sacrificial anodic protection. Second, impressed current cathodic protection. Third, control of corrosion by modifying the metal. And last, corrosion inhibitors. In this, we will discuss from the first sacrificial anodic protection method. In this method, the metallic structure to be protected is made cathode by connecting it with more active metal, such as anodic metal, so that all the corrosion will concentrate only on the active metal. The artificially made anode gradually corroded, protecting the original metallic structure, and this process is known as sacrificial anodic protection. For example, aluminium, zinc, magnesium are used as sacrificial anode. This method is used for the protection of ship and boat. Sheets of magnesium and zinc are hung around the hull of ship. Zinc and magnesium will act as anode compared to the iron, so corrosion concentrate on zinc or magnesium. So they are act as sacrificial anodic protection, and it is known as sacrificial anodic protection method. Important implications of sacrificial anodic protections are protection of underground pipelines, cables from soil corrosion, insertion of magnesium sheets into domestic water boilers to prevent the formation of rust, and third, calcium metal is employed to minimize engine corrosion. And second is impressed current cathodic protection method. In this method, impressed current is applied in the opposite direction of the corrosion current to nullify it, and the corroding metal is converted from anode to cathode. This can be done by connecting negative terminal of the battery to the metallic structure to be protected, and positive terminal of the battery is connected to inert anode. Inert anode used for this purpose are graphite, platinized titanium. The anode is buried in a backfill. The backfill provides good electrical contact to anode. Important applications of impressed current cathodic protection are structure like tank, pipelines, transmission, line tower, marine piers and laid up strips. The next is the difference between sacrificial anodic method and impressed method. In sacrificial anodic method, first is no external power supply is required, and the second difference is this method requires periodical replacement of sacrificial anode. In this method, investment is low. Soil and microbiological corrosion effect are not taken in this account. This is the most economical method when short-term protection is required. This method is suitable when the current requirement and the resistivity of the electrolyte are low. But in second method, impressed current method, external power must be present. Here anode are stable and don't disintegrate. In this method, investment is more, but in the first method, investment is less. And the next difference is soil and microbiological corrosion effect are taken into account. This method is well suited for large structure and long-term operations. And the last difference is in this method can be practiced even if the current requirement and resistivity of the electrolyte are high. Next is corrosion inhibitor. In this we will discuss what are the inhibitors. A corrosion inhibitor is a substance which reduces the corrosion of a metal when it is added to the corrosive environment. Next, types of inhibitors. First is anodic inhibitor. Example of anodic inhibitors: chromate, nitrate, phosphate, tungsten, other ions of transition element with high oxygen content. Anodic inhibitors are those that prevent the corrosion reaction occurring at the anode by forming insoluble compound with the newly produced metal ion. Next is cathodic inhibitor. In electrochemical corrosion, the cathodic reaction are of two types depending upon environment. In acidic solution, examples organic inhibitors such as heterocyclic nitrogen compounds and heavy metal soaps are used. In acidic solution, the cathodic reaction is evolution of hydrogen like amines, mercaptans, thiourea, substitute urea. The reaction is in acidic medium, hydrogen ion is already present and it accepts the two electrons and it converts into hydrogen. That's why it is known as evolution of hydrogen. This corrosion can be reduced in two ways. First is by slow down the diffusion of hydrogen ion to the cathode. This can be done by the addition of organic inhibitors like amine, pyridines, which are adsorbed at the metal surface. And the second way is by increasing the over voltage of hydrogen evolution. And in the case of neutral solution, sodium sulfite or hydrazine is used as inhibitors. In neutral solution, the cathodic reaction is half oxygen plus H2O and it accepts the two electron convert into hydroxide ion. In neutral medium, the corrosion can be reduced by two methods. First, by eliminating the oxygen from neutral solution, thereby formation of hydroxide ion are inhibited. This can be done by the addition of reducing agents like sodium sulfite and hydrazine. And the second method is by eliminating the hydroxide ion from the neutral solution. It can be done by the addition of magnesium, zinc or nickel salts. These react with hydroxide ion from insoluble hydroxide, which are deposited on the cathode, forming less impermeable self barriers. The next method is corrosion can be controlled by modifying the metal. In this, we will include first by the selection of metal. Selection of right type of metal is the main factor for corrosion control. The metal are used in ornament and in surgical instrument. The second is by using pure metal. Pure metal have high corrosion resistant power. Even a small amount of impurity may lead to severe corrosion. Next is by alloying. Corrosion resistance of many metals can be improved by alloying. For example, stainless steel containing chromium produces coherent oxide film which protect the steel from further attack. Next is by proper design. In this, the first point is avoid galvanic corrosion. The galvanic corrosion can be avoided by following methods: selecting the metal as close as possible in the electrochemical series, and the second method is by providing smaller area for cathode and large area for anode, and the third is inserting insulating material between the two metals. From this, we can avoid the galvanic corrosion. Next method to control the corrosion is hot dipping method. The benefits of this method is it is one of the most familiar method. It is very simple process. It gives good results. In this method, the base metal is dipped in a molten coat metal for particular time to get the uniform coating. The next is the condition for successful hot dipping methods are: first, the coat metal having low melting point than the base metal. The second is the coat metal must form alloy with the base metal. The third is the base metal should be withstand high temperature of dipping without any change in properties. And the last is hot dipping is done on iron with zinc, tin and aluminium as coating metal. The first hot dipping method is galvanizing process. It is the process of coating zinc over iron sheet. In this process, the first step is the base metal iron sheet is first pre-treatment with dilute H2SO4 to remove oxide coating present on the metal surface. Then it is thoroughly washed with water. Next, the clean dry iron sheet is dipped in the bath of molten zinc, which is kept at 425 to 430 degrees Celsius, and the surface of the molten coating metal is covered with NH4Cl flux to prevent the oxidation of molten coating metal to its oxide. And the next hot dipping method is tinning process. It is the process of coating tin over iron sheet. Process is in this process the base metal is first pre-treatment with dilute H2SO4 to remove oxide film present on the metal surface. Then it is washed with water. Then it is cleaned dry. Base metal is dipped in a bath of molten tin which is kept at 230 to 235 degrees Celsius. And after this, the surface of molten coating metal is covered with ZnCl2 flux to clean the base metal further. In this process, palm oil is used to prevent the oxidation of molten coating metal to its oxide.